Hey everyone, today we're focusing on chapter 12, section 1. And this is a longer video. There's a lot of content here, so make sure that you're pausing and getting all the notes down when you need them. The topic is adding and subtracting polynomials, and your learning target says, I can identify types of polynomials and the degree of the term to be able to add and subtract polynomial expressions. So we're going to start with some vocab, and we want to make sure that we are understanding kind of what components of the equations we're talking about. So the first term is polynomial. We haven't really put a label on a polynomial expression, but you have seen polynomial expressions. It just means that there are many terms. So it's a mathematical expression involving the sum, and sum can be plus or minus because we can talk about the sum of a negative term, of terms in the form a times x to the k power, where a is any real number and k is a non-negative integer. So your power has to be positive, which means you may have to use that negative exponent law to flip it, but overall, you should be set. Looking at an example, m to the third power plus 8m to the second power minus 10m plus 5. There are 4 terms in this expression. The number of terms also can justify the name of the specific polynomial. So 1 term would be a monomial, 2 terms would be binomial, 3 terms would be trinomial, and so on and so forth. In this particular example, the first term we have is m to the third. The coefficient would be 1 because there's no whole number in front of that variable. The variable is m, and our exponent is 3. So we want to make sure that each term can be broken up into those components, our coefficient, our variable, and our exponent. The degree of polynomial is going to be the greatest exponent in the expression. So for our example, that is equal to 3. So we're going to pause for a minute to just review a little bit of our Math 8 concepts, really just thinking about linear equations, because there's a few applications to linear equations that we're going to be able to use when we think about solving and graphing polynomials. So this first example is just a quick word problem. It says to use Verizon, the company charges $M per minute, plus a flat fee of $F. If my Verizon bill is $120 after talking on the phone for 50 minutes, which of the following relationships between M and F represents our contract? And so this is a multiple choice problem. So we're going to list a couple of options here. Option A is 120 is equal to F minus 50M. Option B, 120 is equal to 50F plus M. C, 120 is equal to F plus 50M. And D, 120 is equal to 50F minus M. So in the problem, we're going to identify M is dollars per minute and F is the flat fee. So dollars per minute essentially is our slope because it's changing with the number of minutes that we use, where the flat fee is essentially our y-intercept. So when we look at our equation, y equals mx plus b, that dollars per minute has got to be our x, and our flat rate is going to be our b. So going through the choices, there's only one option that fits f as being our y-intercept, m as being our slope, with our variable built in. So example number 2 says, given the table of values, what is the equation of the line in y equals mx plus b form? So we're going to list the table below quickly, and this is information that would be given to you. -9, -8, -5, -2, -1, and 0. and then y value is consistently of 2. So in our y equals mx plus b form, m is slope, b is our y-intercept. We can find our y-intercept just by looking at the data table where x is equal to 0, the y value is our intercept. So I substitute that into the equation. And then my slope formula is y2 minus y1 over x2 minus x1. I choose 2 coordinate points, substitute in the values, and solve for my slope. Now 0 over 4 is the same as 0. 0 multiplied by any number turns into 0, so I eliminate that x variable, and I get an equation of y is equal to 2. We're going to move into problem number 2. It says you are an environmental scientist responsible for tracking 2 types of endangered parrots. And we're going to use this scenario to look at adding together polynomial functions in order to create new equations. So an orange-bellied parrot is represented by the function b of x, which equals negative 18x plus 120. And x is equal to the number of years since our current year. So if you have a negative x value, it means it's in the past. If you have a positive x value, it means it's in the future. 0 is obviously right now. Our yellow-bellied parrot is represented by the function h of x, which is equal to 4x squared minus 5x plus 25. So let's graph our information, and we're going to use our calculator to do this. I'm going to enter the 2 functions into my y equals field. And in the remainder of this video, I'm going to be referring to the calculator a lot, so just make sure that you have yours handy. When I graph my lines, it's clear they're very close to the y-axis, so I'm going to change my x maximum and my x minimum to negative 10, positive 10 with a scale of 1. And then I also changed my y scale to 50. Brought my maximum up to about 400 and my minimum down to negative 50. And this is really because when I look at the linear of the 2 functions, my intercept at being at 120, I know that I'm going to need those large numbers on my y-axis. So in order to kind of copy the graph onto my paper, I'm going to look for some key information. I'm going to use my second calc feature to trace my function and find some key points just so that I have my picture accurate to what the calculator shows me. Now, this problem didn't ask me to draw a picture, so I definitely didn't need to. If you're comfortable going back and forth in the calculator, you can do that. However, I just wanted to make sure that I had it on my paper so that you could continue to refer to it while we're working together. So I'm going to take a minute and speed through that visual. So I just notated that my function b of x is the blue line and the h of x is the red line. Number 1 says use the graph of b of x and h of x to determine the function t of x to represent the total population of parrots. Well, if I know my population of orange parrots and I know my population of yellow parrots, presumably I can add those 2 populations together to get the total population of parrots. So I can do the same thing with a function as I would do with a regular value. If I knew I had 57 orange and 63 yellow, I would just add them together. But because I have these functions that represent the 2, I can add the functions together and get a new function that represents the total population of parrots. When I do that, I'm assuming it's still going to be a parabola because I still have an x squared as one of my terms. I am going to go through and collect some data and see what this looks like and then compare it to my graphs to make sure I'm accurate. So I'm going to use the calculator feature and substitute in my x values for each of my functions. So right now I'm working on the b of x. I'm substituting negative 4, negative 2, 0, positive 2, and positive 4. Those are values that I chose myself based on the picture. I wanted to get a good span of data. When I look at the line and I compare negative 4, negative 2, 0, positive 2, positive 4, the y values that I've calculated are pretty accurate in terms of the visual. So I can see on my y-axis where that data appears. I'm going to do the same thing for my h of x and just substitute in -2, -4, 0, +2, +4, and make sure that when I look back at my graph, that the values that I'm calculating are actually present on my equation. In terms of the total population of parrots, I want to make sure that adding those two functions together are going to get me my third data set. So I'm just putting 192 plus 109, 156 plus 51, and I'm filling in that total function. If I added together my two functions, b of x and h of x, the substitution of those variables should come out to be what I calculated just by adding together my two functions. So adding together two functions really just means combining like terms. So I have a 4x squared. I'm adding -18x and -5x to turn into -23x. And then I added 120 and 25 to get 145. So that t of x function, that should be my combined total population of parrots. And it's appearing on my graph as a black line. When I go through and I check those x values for their y pairings, the calculations that I made are coming out viewable on that graph. So that's really helpful because I know that my function is matching the data that I solved for without actually adding the two functions together. So adding those two functions is a skill that is going to be on your IA4. That's why I'm pointing it out. I also want you to think about, when were there the same number of each type of parrot? That is simply an intercept. So I can second calc the intercept for the blue and the red line and pull that information straight from my calculator. My apologies, the screen is off of the page right now, but you would see that data coming directly from the calculator just with your second calc function.